Adding and subtracting polynomials. To add or subtract polynomials, group like terms horizontally or write them in column form, aligning like terms vertically. Like terms are monomial terms that are either identical or differ only in their coefficients, such as 3p and negative 5p, or 2x squared y and 8x squared y. So when I think about looking at like terms, what I'm looking at is everything after the leading coefficient, the coefficient at the front there, everything after that needs to be exactly the same. Kind of like if you think about it like it's a word. So the word after that coefficient needs to be exactly the same in order to add those terms together. All right, so we're going to look at finding some sums here, and we can do this a few different ways. You can group the terms that are alike together and work vertically, or you can think about it horizontally, kind of like our old school addition. So if I asked you to do 326 plus 475, you would line them up vertically, horizontally, vertically. You would line them up vertically and put like terms with like terms. So we can do this kind of either way. Eventually you might become, when it's pretty straightforward, simple enough to do it in your head. But let's take a look at these two. So I have 6x plus 9 plus 4x squared minus 7. So my 4x squared doesn't have any other terms that are like it, so that's on its own. My 6x doesn't have any other terms that are like it, so that's on its own. But my 9 and my negative 7, my minus 7 here, those are alike, so I'm going to group them together. So I end up with a sum of 4x squared plus 6x plus 2. So I can work with this horizontally, or I can, especially for longer polynomials, I would suggest that you stack it vertically. So here what I've done, I've taken my 2x squared plus 5xy plus 4y squared, put that on the top. And then I've taken my second polynomial, which isn't in standard form, it isn't in any form in particular, and I've rearranged those terms so that I have like terms stacked vertically. So I've got my 2x squared, and then I put my negative 6x squared beneath it, so my x squareds are like terms. I have my negative xy underneath my 5xy, because those are like terms. This is 5xy, this is negative 1xy. And then I've put my 2y squared underneath my 4y squared, because those are like. So notice that the only thing that's different about these is the coefficients. So the coefficients are different, everything else is the same. Coefficients are different, everything else is the same. Coefficients are different, everything else is the same. That's how we notice the like terms. And then I'm going to add vertically. So 2x squared minus 6x squared, I've got 2x squareds. I'm going to take away 6 of them. That leaves me with negative 4x squareds. What's after the coefficient doesn't change. The only reason I can add these is because they are alike. So when I'm done with them, they are still whatever they were. These are x squareds, these are x squareds, they're still x squareds. I've got my 5xy minus 1xy, so that leaves me with 4 xy's. Again, I'm just ending up with 4 of whatever it was I started with, which was xy's. And I have 4y squareds plus 2y squareds, which when I'm done leaves me with 6y squareds. So when we add, we can work horizontally or we can work vertically. Let's take a look at subtracting. So when we subtract, we want to pay attention to our distributive properties, what we really want to make sure we don't forget about, especially when we're working with our parentheses around our polynomials. So our first difference here, 8p minus 5r minus, and then in parentheses, negative 6p squared plus 6r minus 3. So again, what I've done here is I've kind of rewritten it using the distributive. I've taken my negative and I have applied it, multiplied everything inside those parentheses by a negative 1. Because remember, that's like a negative 1 out in front there. So negative 1 times negative 6p squared gives me a positive 6p squared. Negative 1 times the 6r is a negative 6r. And the negative 1 times the negative 3 gives me positive 3. So don't forget to distribute that negative when it's in front of the parentheses like that. So here then I can regroup, and I've got it rewritten, and now I can group like terms. So I have my 6p squared. There's no other like terms here. Since this is just addition, I can kind of move things around. So 6p squared. My 8p doesn't have anything like it, so that's by itself. Now I have negative 5r and negative 6r, which gives me a negative 11r minus 11r. And then my plus 3 hangs out on its own. So I end up with this polynomial for my difference. And one more, a little bit longer. Again, when they start to get long, I would highly suggest that you work vertically to organize your like terms. It's just kind of easier visually to see how they are arranged. So I have my first expression here, my first polynomial I've listed it on top. My second polynomial I wrote underneath it, and I made sure that I'm lining like terms up. So I have my x squareds, I have my xy's, and I have my y squareds. Now I wrote this out originally as subtraction, and then I went through and I changed it using the distributive property. I'm going to change this to adding the opposite. So I'm going to change this to addition, and I'm changing everything inside to its opposite. This should kind of look like our systems of equations when we were adding two equations together or subtracting two equations to eliminate a term. That's pretty much what this feels like. Same kind of pattern to it. So now it's addition, so I can just add down. 4x squared plus x squared gives me 5x squareds. 6xy minus 2xy gives me 4xy. And 2y squared plus 5y squared gives me 7y squared. So adding, subtracting with polynomials, one of the things you want to pay attention to is making sure you put like terms with like terms, and then they add up, they end up as that like term. And also pay attention to when we're subtracting that you distribute that subtraction over the entire polynomial.